All right, welcome everybody to chapter 4. We're going to go over some things. It's also a review from micro. We're going to talk about supply and demand and how equilibrium comes together. So here's the questions that I want you to think about. We're going to think about demand, buyer's demand. This is really typical economics, right? This is like the economics chapter. If you've ever had economics before, you've probably had this chapter. So I won't dwell on it too long. But if you guys have questions, feel free to ask. What factors affect the supply? What factors affect the demand? How does supply and demand come together and have a price and quantity? Then if we change those things, how does the price and quantity change? That also answers that last question about how do we allocate goods. All right. Well, let's get started and first talk about a couple of definitions. A market is a group of buyers and sellers of a particular product, right? So a market doesn't have to be a store. It can be. It can also be eBay. It can be any place where you have a buyer, a seller, and some product, and exchanging is going on. All right. So this is a really, really loose term, right? You can think of the black market, which is doesn't really occur in any one place or under the auspices of any governmental control either. In particular, a specific type of market we're going to talk about is a competitive market. Okay. Just like the term implies, competition. You have a lot of buyers and a lot of sellers. And since you have so many buyers and sellers, the price is driven as low as it can. And if you purchase goods, because you're just one small buyer in a sea of many buyers and sellers, you personally can't affect the price. And the same as the seller. You personally can't affect the price. Okay? Just because there's so many buyers and sellers, if you try as a seller to raise the price 1 or 2 cents, everybody's going to leave from you and go to the other buyers that are just there, selling it cheaper. Okay? That's the definition of a competitive market. In a perfectly competitive market is like, all the assumptions for competitive to perfection, right? All goods are exactly the same. Buyers and sellers are so numerous that no one can affect the market price. Everybody's known as a price taker. They're not allowed to set the price or be a price maker. They're having to take the price as fixed. So in this chapter, hopefully you look at these assumptions, you're like, wow, these are really bad assumptions. This doesn't actually occur in real life. True, and most times it doesn't occur. But for purposes of just explaining how we analyze markets in economics, and that's all that you'll need to know for this class, nothing too technical, we're going to assume that all the markets are perfectly competitive. Okay? All right, so first we're going to talk about demand. Everybody knows in economics we have the 2 main things to talk about is supply and demand. All right, let's talk about demand first. What does that mean? Well, the quantity demanded is another definition. Quantity demanded of any good is the amount of the good that buyers are willing and able to purchase. Okay, at a certain price. Okay, so if I tell you that bottles of water cost $1, and then I ask how many people in this classroom want one, I get the number. That's the quantity demanded. Okay, it's pretty simple. And there's this thing called the law of demand, and it also makes sense. If I then start charging you more for those bottles of water I just talked about, if the price goes up, quantity goes down. These things are inversely related. As price goes up, quantity goes down. All other things equal. Okay. That's important. That's known as the ceteris paribus assumption in economics. That's Latin for literally everything else is equal. And so when I think of a demand curve, I can only think, and I'm sliding along a demand curve, I can only think of price and quantity because everything else has to stay equal. Okay, I'll show you in a couple minutes how to deal with other things changing, right? But if I just got one demand curve and it's already drawn, I can only think about price and quantity moving, ceteris paribus, everything else being equal. Okay, so if we want to talk about the quantity demanded at different prices for an individual, we use something called the demand schedule. Okay? And you can present it in a tabular or table format. Okay? There's three ways to actually talk about demand. You can show it in a table. It's called demand schedule. You can show it in a graph. It's called demand curve. You can show it in a function. It's called the demand function. We'll only look at the table and the graph in this class. Okay? So what do you notice? This is this seems to make sense. If the lattes are free, all right, we're gonna have a fictitious good called a latte, right, like a coffee. And we're going to have this lady named Helen, and she's going to demand a certain number of lattes. When they're free, she wants 16 of them. As the price increases, the number that she desires goes down. Okay? Why do they go down? Well, there's a million different reasons why this goes down, but I mean, maybe she doesn't have enough money to pay for them all. Maybe she just would rather use her money to go buy something else, right? This is the person's preferences are all kind of encoded into this one line. And her preferences here definitely obey the law of demand, right? As the price goes up, the number of quantity the quantity demanded goes down. And if the price continued to go up, eventually this price will probably, or the quantity will go very close to 0, if not approach 0. Okay? So this makes sense. Let's go ahead and graph it on a curve. We call it a demand curve. Even though this will end up being a completely straight line, we still call it a demand curve. So don't let the word curve confuse you or anything like that. But here's how we draw a demand curve. Some things to note. Price is always on the y-axis. Okay? Quantity is always on the x-axis. I think in economics it always is very helpful to pay particular attention to the labels of the axes. Okay? Because, for example, in Chapter 3, we just learned about production possibilities frontiers. Right? They have one good on the y-axis and another good on the x-axis. And if you look at the axes and you see that there are two goods, you know that it can't be a demand curve. You know the only thing that we know so far with two goods on the axes is a PPF. Okay? In the same way, when you see price and you see quantity, even if you don't know what's exactly going on in here, you have a good clue that it's either a supply curve or a demand curve. Okay? And here's how we draw a demand curve. I look. Every point has two pieces of information. I have a price and I have a quantity. Right? Every point, when I graph, has two pieces of information, the x-axis and the y-axis. So I'm just going to look. And when the price is 0, she wants 16. Okay? So I'm going to get a point that's at 16. And then how high or low will it be? Well, it's going to be at 0 on the y-axis. Right? So I put it over here at that point right there. And that's that first point. Now when I go to the second one, it's rather simple. I go down to 14, 15, 14, but then I go up to $1 because that's what this information is telling me. Okay, so that's this point. The same thing, when the price goes up to $2, I drop to 12. Okay, and then the same thing for the rest of them. Finally, the last thing that I do is I connect them all with a line. And that's known as my demand curve. Okay? This is a really convenient way to synthesize all the information. There's really quite a bit of information in this table, and I'm able to fit it all into one graph. It's a convenient way of summarizing or synthesizing all of this information. Okay? So it tells me the quantity demanded of Helen at every price point. So what we just talked about was an individual demand, but remember we talked about a market. That's a bunch of individuals, a bunch of buyers and sellers. So we might find it useful to draw something called a market demand curve, which is just adding up how much everybody in the market wants, not just what an individual wants. Okay? So suppose now there are two people in the latte market. Right? This obviously is not a perfectly competitive market right now because you have to have many buyers and many sellers. But just for an example, let's suppose that the latte market consists of two buyers, Helen and Ken. So the individual demand curve of Helen was the one that we just saw. Ken will also have his own individual demand curve. When I put them together, that's going to be the market demand curve because they're the only people in the marketplace who are going to buy a latte. Okay, so there's Helen's demand schedule that we just looked at on the last slide. Here is Ken's demand schedule. And the market demand schedule, I know this is super deep. You just add them together. So how many total lattes will be demanded if they're free?
24.
24. I just take 16 and I add 8. And I got 24. At $1, it's 14 plus 7. We got 21. At $2, and at the other ones. Okay? So I have this market quantity demand or market demand schedule right here. It gives me the quantity demanded at every price point, and it also obeys the law of demand. But this time it tells me the total amount desired to be purchased at any price. Okay? Now, let's go ahead and graph that. It looks like this right here. Oops. It looks like this right here, where I have just taken this market demand schedule and transferred it into a market demand curve. Now, if you have two demand curves, what you'll do is you'll horizontally add them, right? Because Helen's was over here somewhere, and Ken's was over here somewhere, and you just add them side by side, and that's how you get a demand curve. If you just have a demand curve, okay? It's in the world of mathematics, it's horizontal summation, right? You just add them up side to side. If you have the numbers, that's convenient too. You can just add them like I showed you. All right? So let's now go to the world of not ceteris paribus. Remember I told you demand curve told you how quantity changes in response to price, and nothing else was allowed to change, right? Because of the ceteris paribus assumption. Let's delete that assumption and talk about how we deal with other things that could change, right? Because it's possible that I go to the store and I buy the latte. Yeah, the price has a lot to do with it, how many I buy. But there are probably a lot of other things that have to do with my decision to purchase lattes, okay? And so let's talk about how to analyze these other things, all right? So that's what I just said. With the ceteris paribus assumption, the demand curve shows how price affects quantity demanded. But the other things are non-price determinants. Okay? So in order to be an other thing, it has to be non-price. And what they do is it actually just moves the demand curve. That's how we deal with it in economics. Right? That's how we deal with it. So we shift the demand curve. Let's imagine. If the number of buyers in the market shifted, let's say it increased, how do you think this would change the market demand curve? And to give you a hint, remember earlier we had Helen's demand curve, and then I think we had Ken's demand curve. And how did we find the market demand curve? We added them up horizontally, right? We did this one, and then we took this one, we put it on top, and then we got to this guy, right? What happens if we add somebody else who wants lattes also? The number of buyers in my marketplace is increasing. What does that do to the demand curve? Shifts it to the right, also known as an increase. All right. So there's a couple ways that I can say this. Demand increased. Demand increased. Right. The demand curve shifted to the right, or even if you want to call it shifting up, you could use either of those terms. But this was due to the number of buyers. Okay, it shifts the D curve to the right, and so sorry, I went over that one quickly. So increase in number of buyers shifts the demand curve to the right, and let's look at what it does to the graph. Let's just imagine that at every price point, 5 more people want to buy the good. So every price point, 5 more people, or 5 more of the good is purchased. Okay? I just draw a new demand curve where everything is shifted over 5. Okay. So that's if buyers increase. Okay. What about if income changes? If the income of the people buying the product goes up, right? If I go to the store and there's lattes and I'm only able to buy 4 every week, but then I get a raise, what's that likely to do to the number of lattes that I demand? If I like lattes, I guess. It will increase, right? Given that I like lattes, given that lattes are a normal good, it will definitely increase. At every price point, actually, right? And so since at every price point it increases, it does the exact same thing. It looks like an increase in the number of buyers, okay? Increase in income shifts it up. And this is for a normal good. It shifts it to the back, to the right. There's this thing called an inferior good, okay? And this is actually just defined as things that when you get richer, you buy less of them. This does not happen a whole lot, but I think the usual example of this thing called an inferior good is top ramen. You guys know what top ramen is, right? All stuff in the styrofoam cup, and you put the water and you put it in your microwave. We probably all eat a lot of them right now. Maybe, I don't know. But as our incomes increase, are we going to still keep buying more top ramen because we can afford more top ramen? No, we're going to switch probably to something a little bit yummier, right? I don't know. Maybe we're going to go to the store and buy real noodles or something. Okay, maybe make spaghetti. So if it turns out that when people get richer, we notice their demand curve slides downwards, then we call that an inferior good. Okay? So for analysis in this class, you just have to ask yourself a simple question, and generally if there's a question on this, I'll highlight it. Is this a normal good, or is it an inferior good? Okay? A normal good will shift the demand curve up, inferior good will shift it down. Okay. Another thing, prices of related goods. Think about this, right? I have these things called substitutes. So if two things can substitute for each other, maybe lattes and Red Bulls, right? If I'm just trying to get caffeine, lattes and Red Bulls are good substitutes for each other, right? So let's say that my income doesn't change, the price of the latte doesn't change, nothing on that changes, but the price of Red Bulls all of a sudden goes cheaper. I might start buying more Red Bulls and fewer lattes, right? Nothing else has changed. Nothing in the world of the latte has changed, right? But because the Red Bull and a latte, perhaps for me, are substitutes, I'm substituting my ability to get caffeine, okay? Another example is pizza and hamburgers, right? If pizza becomes more expensive, I'm not going to go to Pizza Hut quite as often. I will go to Carl's Jr. instead, right? And so my demand curve will shift up for Carl's Jr. Okay? So notice, this is a non-price determinant because I'm talking about it's not the price of the good I'm talking about. It's a price of some other good, right? And that's why I have to change the demand curve. Okay? It's the price of another good. The only thing this P and this quantity refer to whatever good that I'm buying and selling. The lattes, for example. Right? This price refers to the price of the latte. If the price of something else changes and it changes my demand, okay, it's either going to be a substitute or this other kind of good called a complement. There's some other examples of substitutes before we go to complements. Coke and Pepsi, laptops and desktop computers, CDs and MP3s. Okay. Now these things are complements. It is kind of the opposite of a substitute. It's something you have to buy with the good you're buying, right? So maybe in your lattes, you like to have whipped cream on top or something like that. So you have to buy whipped cream and lattes, right? Well, if whipped cream gets more expensive, then I'm going to buy less whipped cream, which means I'm going to buy less lattes, even though the price of lattes is not changing. Okay? So therefore, I have to show that by a change in the demand curve, because it's It's something other than the change in the price of the latte. Some other example are computers and software, or Android phones and apps in the Google Play Store, right? As Android phones become cheaper, more people buy them. That increases the demand for apps for my phones, right? So we have to think about prices of related goods changing the demand for the good that I'm analyzing. Okay, so you can think of it, college tuition and textbooks, they go together. Bagels and cream cheese go together. Eggs and bacon go together. All right. So another demand curve shifter. Kind of abstract, nebulous idea known as tastes, we call it. I don't mean actual taste like stuff you put in your mouth. I mean like preferences. Right? For some reason, some things just start becoming more popular and people want to buy them more. Okay? That shifts the demand curve. It's not a price of the good, right? They just want more. So an example is the Atkins diet. I don't know if you guys remember that, but you have to go all protein heavy. And anyways, everybody bought a bunch of eggs because eggs are, I guess, high in protein and fat and low in carbs or something like that. So the egg demand, the price of eggs didn't change. So I'm not sliding along a demand curve. The actual demand curve itself changed because people just wanted more eggs at every, no matter what the price of eggs were back then, they just wanted more eggs. So the way I represent that is by moving the demand curve to the right. Okay? On the flip side, if people start hating the good, then the demand curve is going to fall. Okay? That's the way that we analyze it using our economic tools right here, the supply and demand curve. Okay? Another thing that can move the demand curve is expectations. You may not have been able to think about this one, but think about it. If people expect their income in the future to rise, right, expectations, you might start going out and buying nicer things, going to nicer restaurants. So maybe your demand curve for expensive things starts moving up. Right now, even though my income hasn't quite changed yet. Okay? And on the other hand, if the economy is going downhill and people are worrying about not maybe having a job in the future, people might start cutting back. Even though their income right now hasn't changed, if they're just worried about the future, they may purchase fewer things right now. Okay? So here's a nice summary table, and you really should know this. Okay? If price changes, if we're talking about the price of this good, you just slide along the demand curve, okay? And the appropriate way to think about this, right, is maybe I was at this point for a certain price and quantity, and the price dropped. I'm at this point, okay? Demand itself did not change. Demand, i.e. the demand curve, did not change. What changed? The quantity demanded. Right? This is really important that you guys understand the difference between demand versus quantity demanded. Right? If just quantity demanded changed, that's just like one of these things. If all of demand changed, that means quantity demanded at every price changed. Okay? It's the difference between demand changing versus quantity demand changing. Okay? So I think this chart is helpful. If it's the price of that good, it's a shift along the demand curve. The demand curve does not move. Anything else that affects demand, though, does shift the demand curve. Okay? For those of you who are more mathematically inclined, really what we're doing here is this is a two-dimensional representation of a multi-dimensional graph, right? We have maybe price, and then in another axis, maybe we have incomes of the individuals. In another axis, we have price of related goods, right? And there's some multi-dimensional graph that is telling me how much quantity demanded. And all we're doing is we're just taking a slice of that graph where everything else is being held equal, and the only thing we're allowing to vary is price. That's why we move the demand curve, if you're wondering why that happens. Okay? It has to do with the fact this is actually a multi-dimensional graph. We can only represent in 2 dimensions because frankly, I don't know how to draw in 5 dimensions. All right? OK, so any questions on demand, what shifts demand? CDs, things like that. Okay, awesome. Let's draw a demand curve and then move it. And then we'll do that 3 times. And the demand curve itself is for music downloads. So this is the quantity of music downloads, so like MP3, and this is the price of MP3s. And so just draw one. And then what I want you to do is figure out what happens if iPods go down. And figure out what happens if the price of music goes down. And figure out what happens if the price of CDs go down. So you'll need to draw 3 different ones. And on your handout, there's a blank spot to draw the music, or the demand curve. So in each one, you'll need to draw 2 demand curves. You'll need to draw the original and then the changed one. The original and then the changed one. OK, so for the first one, the price of iPods falls. What is that likely to do to the demand curve for MP3s? What do you think? Or if you don't know exactly what, tell me, why am I talking about the price of iPods when I'm talking about MP3s? What does that have to do with MP3s? Where do you listen to your MP3s? On a iPod. At least you used to before we all had phones and iPads and iPhones and all that. OK? So there were these things called iPods, by the way, and people used to listen to music on them before we had all these other things. And so if iPods get cheaper, are people likely to buy more iPods? Yes. If people buy more iPods, what's that going to do to the market for music downloads? Make it increase, right? So the way that we represent that on our graph for the market for MP3 players, because the price of the MP3 player itself is not changing, right? We're going to represent that with a shift out of our demand curve. So it'll look like this. There was the original one, and their complements. They're consumed together. When the price of iPods fall, people buy more. Therefore, people also want more music downloads. Shifts out to the right. OK? So that goes in the category of prices of related goods of the demand shifters. OK? All right, let's look at the next one. The next one was the price of music downloads falls. What's that going to do to the demand curve? What's that? So we have some people saying it's going to shift to the right. We have some people say it's going to do nothing. It's true, it's nothing. This is a trick. This one is very, very tricky. The price of music downloads falls. This is the price of music downloads, right? When I'm talking, the only thing that doesn't shift the demand curve, the only thing that doesn't shift the demand curve is the price of that good that we're talking about, right? So we're talking about music downloads. When the price of music downloads falls, the curve itself does not shift. Demand does not change. However, you are right that quantity demanded changes, right? Quantity demanded changes. And what is quantity demanded going to do? Increase, right? So demand itself does not change. The curve itself does not change. But quantity demanded does change, all right? Because the price point dropped and the quantity increased, OK? So this one's in there to make sure you guys are paying attention. The only thing that does not actually move the demand curve is the price of that good. Everything else will move the demand curve either to the right or to the left. OK? Finally, price of CDs fall. Decrease or nothing? OK, so some people are thinking nothing. Some people are thinking decrease. It definitely, CDs are a substitute, right? So this is the prices of related goods again. If CDs get cheaper, I'm just going to go buy the CD instead of downloading off iTunes, right? OK, so Nothing changed in the world of the music downloads, but people are buying less of it, so that must mean a shifter. All right? So it's actually going to shift to the left. You guys are 100% right. Okay. Shifting to the left. Boom. All right? Because I just go buy the CD now. It's cheaper. Okay? Instead of downloading it. And then I load it onto my iPod after that. All right. So in the same way that we talked about demand, we're going to talk about supply. It's a very similar procedure. Okay, so we'll go through it maybe a little bit quicker. Okay, so the quantity supplied is the amount that people are willing to supply. So I'm not thinking about the purchasers or the buyers. I'm thinking about the firms or the producers, the people that are making whatever the good is. Okay? That's what this supply idea is. All right? And the law of supply, very similar to the law of demand, except for opposite, the law of supply. If you're selling a product, if you're a firm and the price of the product in the marketplace is going up, you're going to try to sell more of it. You're going to produce more to try to sell more to capture extra profit from the rising price. Okay? Whereas the law of demand for the buyer meant that prices going up are a bad thing, so I buy less. The law of supply for the seller, prices going up is a good thing, so I'm going to sell more. Okay? And that's what the law of supply tells us. All right. So in the same way that we can write down a demand schedule, we can write down a supply schedule. We'll do it on a table form or tabular format first. Okay? So in the demand side, there was Helen and Ken, and they were buying these lattes, right? On the supply side, someone's got to be making the lattes. There just so happens that there's this company called Starbucks, and they make lattes, right? So let's imagine that we're Starbucks now. We have to switch our brain, okay? So if you're not able to sell lattes for any money, are you going to want to make any? No, right? So this is the opposite. I might want to buy 1 million of them because they're free, but I'm not going to make any if I'm Starbucks, right? As the price goes up, the quantity starts going up, right? So notice that this is the law of supply, and Starbucks' supply schedule is following the law of supply. Okay? As they can sell the price more, the quantity's increasing. Okay? Now, it's useful to note at this point, because some people kind of get confused about this, and they're like, wait, like, can't Starbucks just set the price at whatever it wants? Well, maybe, but we're, remember, assuming for purposes of this chapter that the marketplace is perfectly competitive, right? So the Starbucks just shows up to the latte market, and they're just told how much they have to sell it for. Okay? That's the key to the supply curve. Some people kind of get confused about the supply curve. I did, actually, when I first took econ, principles of macro, in a community college way a long time ago in San Diego. I couldn't figure this out. I was like, what the heck's going on? Starbucks just changes their price. What they're going to... This is like they're showing up to the marketplace and they're just being told how much. And then they respond by saying, you know, someone tells Starbucks, you have to sell your lattes for $3. So Starbucks responds by selling 9 of them, right? Or this is okay, you can sell them for $4 now. So they respond by selling 12. Okay, that's the key to understanding the law of supply. Because it's a perfectly competitive marketplace, you as the seller don't really have a choice. You just have to sell what everybody else is selling them for. Because if you try to sell for a different price, everybody's just going to go to the other guys, right? That's the idea here. So that's why we imagine that somebody's coming and telling Starbucks how many they can sell. That's where the law of supply comes in. Okay? So let's go ahead and graph this the same way. We have a 0 price, a 0 quantity supplied. So we're going to put a dot at 0, 0. This is known as the origin of the graph, right? Because every point gives us 2 pieces of information, the x-axis and the y-axis information. So we put a point there at 0, 0, and then we put one at 3 lattes and $1. 3 lattes and $1. Okay. We go ahead and do that for 6 lattes and $2, so on and so forth. And we draw a line through it. This gives us our supply curve. All right? Don't get freaked out. It's called a curve, even though it's a straight line. Sometimes it's curved, sometimes it's straight. We just call it a supply curve. Okay? Any questions? All right. In the same way that there was demand of individual people, and then we add them all up to get a market demand, in the marketplace for lattes, suppose that Starbucks is not the only provider. Maybe there are other sellers, right? So we're just going to look at the market supply. It's really similar analysis as we did for demand. It's just the sum of the quantities supplied by all sellers at each price. So we're going to go ahead and suppose that in addition to Starbucks, which the demand schedule I previously showed you a couple slides ago, there's also this other firm called Jitters. Okay? And they also sell. And of course, their supply curve doesn't have to be identical to Starbucks's, right? They might have different costs or different technology. It does follow the same trend, the law of supply, right? As price goes up, quantity supplied increases. Okay? And so the market quantity is just a horizontal summation of the price, right? So at $0 in the marketplace, the total number that Starbucks produces is 0, the total number that Jitters produces is 0, and the total number produced in the whole market is, of course, 0. All right? And so we can add that up. The market supply should be bigger than each of my individual supply curves, but it should also still obey the law of supply. And if I graph that, I just take the supply schedule, the market supply schedule, and I turn it into a graph. If you don't have the actual numbers and all you have are the graphs, you'll have one person's supply curve and the other person's supply curve. You just add them up horizontally, same way as demand. Okay? Except for this time, supply points to the sky. That's how I remember it, in case you guys forget. Sometimes I forget which is which. Supply points to the sky, and then demand points down. That's how I remember it. When you draw them a lot on the board, I sometimes mix them up, and then it's just embarrassing. So supply sky, demand goes down. OK, let's delete this demand curve real quick. OK, so the same way as the demand curve, the supply curve shows you how price changes with quantity, ceteris paribus, all other things being equal, right? So as the price of MP3 changes, the quantity of, I don't know, whoever makes MP3s, Shakira or something, right? it goes up and down, right? All else being equal. If other things change, and it's likely that there are other conditions in the market that are going to induce sellers and suppliers to change the amount supplied, we have to incorporate that in our analysis by changing the supply curve, right? So this only works for everything else being held equal. The only thing that can change is price. If anything else changes, we call it a supply curve shifter. Okay? So all other things are non-price of the good we're talking about, determinants of supply. And so if they change, it shifts the supply curve. All right. So let's talk about the first one, input prices. So this is where it starts getting a little bit different than demand, because remember, we have to imagine that we are the factory or the firm, the supplier, making the good. So what kind of things matter to us? Well, how much do my inputs cost, right? How much are the things that I use for production cost? Okay? So maybe one of your inputs is physical labor, and so you have to pay people's wages. Maybe the prices of raw materials. If I'm Starbucks, one of my inputs for lattes is milk, right? They steam the milk, I think, or something like that. I don't know. I'm not a big coffee drinker. Something like that. I've been told latte is Italian for milk because there's milk in it. At any rate, that's neither here nor there. If milk goes up, for any price, that I can sell it for, I'm not going to be able to make quite as many lattes, right? So that's going to be the same as my supply curve shifting down or shifting to the left. Okay? So if input prices fall, stuff becomes cheaper, right? Let's say wages fall and I don't have to pay my employees quite so much for whatever reason. Now suddenly I'm going to be a more profitable firm, and for any price that I can sell it for, I'm going to make more of the product. Okay? And the supply curve shifts to the right. Okay? So let's call this curve supply S prime or supply prime. When supply increases, it goes to the right. Okay? When supply increases, it goes to the right. When supply decreases, it goes to the left. Another way to think about it, when supply curve comes down, it's going up. Okay? Don't get freaked out by this. Right? When the supply curve itself is being drawn is going down, that means people are ready to make more of the product. So supply itself is going up, even though the supply curve is coming this way. Okay? Input prices. Here we go. Here's the example actually I just gave you. Suppose the price of milk falls, lattes will be able to be increased. So at every price point, Starbucks can make 5 more lattes because lattes are just being cheaper for them, right? Lattes are becoming cheaper. So we got a new supply curve. So supply is increasing as it comes this way. Supply is increasing. Supply is decreasing as it goes that way. All right? So another one, technology. I'm a firm, and I'm producing things. If I can suddenly produce whatever it is that I'm making for a cheaper price, then, or maybe a more efficient output process, not a cheaper price, a more efficient output process, there's less waste, I'm able to sell more for any price that I'm told, right? Okay. So imagine there's some cost-saving technological improvement. We learn to make Starbucks lattes with less milk, for example. That saves me money as Starbucks. So at any price that they tell me, that the marketplace tells me, I can produce more lattes. So my supply curve shifts to the right. Okay, number of sellers. This one is very similar to the demand curve, right? When there was more buyers, it made the demand curve shift to the right, or made demand increase. When there's more sellers, what's that going to do to the supply curve? It will make it increase, which is the same as a shift to the right. Right? If there's more sellers, the supply curve will also come out. And the way to think of that is, right? Let's say there's this $1. And so at $1, Starbucks is willing to make this many lattes. Well, if other firms come in, however many they can make, we just add those on, still at $1 price, right? And they're able to make more quantity. So the quantity increases. And that happens at every price point. And this is how an increase in the number of sellers increases the quantity supplied at every price and shifts the S curve to the right. Okay? So this one is very similar to the demand curve. Expectations. This was also in the demand curve. Let's say that we have a war in the Middle East, and I don't know, ISIS starts attacking like all these other countries, or all these other cities, and starts taking away Kurdistan and Iraq, and turning into the Islamic State of Syria or whatever it is. At any rate, people are getting worried about higher oil prices. Okay, so what do you think that owners of Texas oil fields are going to do? Well, they're like, dude, in about, I don't know, 2 months, we're not going to have any oil from the Middle East. Oil is going to go sky high. I'm going to go ahead and store oil in my big oil tank so that when the price goes up, I'm going to sell it all then and make a killing, right? So that's going to make, so if people are like hoarding oil, which happens, by the way, what's that going to do to the supply curve? It's going to make it decrease right now. Even though nothing has changed right now, right? The price of the oil hasn't changed right now, which would be a shift along the supply curve. None of the number of suppliers hasn't changed. Nothing has changed. It's just people start hoarding oil because they're expecting a higher future price. So it's going to shift down supply right now in the short run. Okay? So the S-curve shifts to the left. Okay, so, I mean, this happens all the time. If a good is non-perishable, like oil is, right? You can't like store up apples for some future year when apples can be sold for a lot of money, right? If it's a non-perishable good, you can store it. And this happens all the time. Okay, happens all the time. So here's this nice chart again for variables that influence sellers. Okay. When it's the price of the good, it's just a shift along the supply curve. When it's a price of the good that we're talking about, it's a shift along the supply curve. Everything else, maybe it's a change in the input prices, like what you use to input for your product, change in technology, change in number of sellers, change in expectations. These all shift the curve either to the left or the right, depending upon what the situation calls for. Okay? All right, let's do this active learning. And we're going to draw the supply curve for this thing. So the product is tax return preparation software. TurboTax, right? You like go to Best Buy and you buy this little yellow box and you come and you install it on your computer. It helps you do your taxes, right? Okay, so we're going to imagine that we're doing supply curve for TurboTax, right? We're the factory making TurboTax here, right? Because that's what a supply curve is. So I don't know. Maybe it's Intuit. Maybe. I think maybe they make TurboTax. I'm not sure. But let's imagine that retailers cut the price of the software, a technological advance happens, and a professional tax return preparers raise the price of the services they provide. So on the next page, draw 3 supply curves, the old one, and then 3 new ones, or whatever happens to it. And you really have to pretend that you are the company that is making it. And then they'd give it to Best Buy to sell it, right? So Best Buy is the marketplace, right? And I'm just being told by Best Buy whatever price that I'm going to get for it, right? Best Buy says, OK, we're going to sell your product for $25. And then I'm like, OK, I'll make a certain amount for $25. OK? So that's the way to think about this. Otherwise, this is a really confusing exercise. OK. So what's happening in A? What is happening in A? Best Buy is cutting the price of the software. So they're telling the factories, all right, you're going to sell this for a cheaper price, right? So what does that do to the supply curve? Yeah, so some people think it shifts. Some people think it stays. Let's think. What is happening here? This is a change in the price of the product itself. I'm the factory making the tax return software. I give it to Best Buy, and then they say, OK, we're going to sell it for 20 bucks, or we're going to sell it for 40 bucks. Okay? Suddenly, Best Buy is telling me that they're dropping the price on me. Okay? So I'm the factory, or I'm the producer. It's as if the price I am able to sell the product for is dropping, right? So the only thing that does not shift the supply curve is what? The price of the same good, right? And so this is definitely a time when it's just the price of this good is dropping, which does not shift the supply curve, okay? It is only a shift along the supply curve, right? So we would say that quantity demanded changed, right? But supply did not change, right? Supply itself did not change because the supply curve didn't. It just is a change in the price, okay? All right, and that is this one right here. So we had one price and quantity. supply curve does not shift, the price falls, the quantity falls. Okay? All right, let's do this next one. We have the fall in the cost of producing the software. So you can either think of this as like the technological change. Somehow I get some better coding program, or maybe my engineers, my computer engineers are cheaper for some reason. But what does that do? Okay. Does it change the price that I'm able to sell the product for? No, it has nothing to do that. This is all, we're talking about input prices. We're not talking about output prices, right? This is the output price of the product. I'm not talking about the input, the costs of the inputs. Okay? So it's not a change in its own price. So it's probably going to be a shift in the curve. Okay? And let's think, what's it going to do? If it gets cheaper to produce the software for any price point, am I going to be able to produce more or less? More, right? So at price P1, I'm going to be able to produce more of the product because it's cheaper for me to produce it, right? If that happens at every price point, what just happened to the supply curve? It shifted to the right. Okay? We call that an increase in supply and an increase in quantity supplied. Okay. Oops. You know what? I just saw, you guys didn't catch me here. This was quantity supply change. Sorry. Note that, online students. This was quantity supplied changed for the last example when Best Buy cut its prices. The quantity supplied changed, but the supply did not change. Now for this instance, this is the fall in the cost of producing the software. Supply increased. Supply definitely increased. And we represent that with a movement to the right of our supply curve. We represent that with a movement to the right of our supply curve. OK. And then finally, professional tax preparers, such as H&R Block, raise their prices. So what category is this? Yeah, exactly. So what happens when substitutes change their price? I give you a hint. This is a trick. What's the only thing that changes? We went over it just about 7 minutes ago. What's the only thing that changes when substitutes change their price? What curve? Demand curve, right? Does supply curve even change at all? No, right? It has nothing to do. It has nothing to do with it, right? It's just the demand curve, not the supply curve. Okay? That makes sense to everybody? So welcome, guys. We're going to finish Chapter 4 right now. Before we start with Chapter 4, let's do kind of like a little review. Remember what we went over last time we looked at Chapter 4, right? We looked at how to determine a demand curve and the things that shift the demand curve. We looked at how to determine a supply curve and the things that shift a supply curve. And today, what we're going to do is we're going to put them on the graph and look at what's called the equilibrium. Okay, this is our main way of determining price and quantity in this class. So this is a really, really important skill to be able to do, is to find this thing, its equilibrium. Now remember, when in our marketplace, remember we had this girl named Helen and another person. They were buying lattes, and there were Starbucks and Jitters, and they were selling lattes. And we wrote this supply schedule and demand schedule that talked about how many people would be willing to buy versus how many people would be willing to sell at any price. Well, the key here is how to determine the price, right, which is going to make the quantity supplied and the quantity demanded equal. So the amount that people want to buy equal to the amount that people want to sell. With our simple model of a supply and demand curve, it actually turns out to be really, really easy. We just plot the curves on the price and quantity axes, right? And we look for the intersection. Now this intersection point is basically the idea here is it's the price which makes the number that people want to sell, that's the supply curve, right, equal to the amount that people want to buy. And so we call that an equilibrium. You might have heard this as a term known as homeostasis. I don't know if you've ever taken biology classes. It's the same thing. It's like the place that the economy or the organism in biology ends up being stable at, right? So it ends up getting to this price, in this case $3, because both the suppliers and the demanders, there's an equal amount supplied and demanded at the same time. Okay, so if you remember, this was our demand schedule right here, and this is our supply schedule right here. It's just the listing of all of the quantities at every price. So remember, the market demand, these people wanting lattes, if there was being sold for $0, they wanted 24 of them, but how much did people want to sell? 0. Right, exactly. And why is that? Well, if you tell the Starbucks, oh, you can only sell your product for $0, clearly they're not going to want to sell any, right? Okay. So remember, the idea was that because both of these, the firm and the buyers, both of them are price takers, okay, in this model that we've made. And that means that they just show up at the marketplace, wherever the marketplace is. It doesn't have to be an actual marketplace. It can be online or something like that, right? And they're told, the demanders are told, OK, the price for the day is $2. Tell me how many quantity you want. All right? And the suppliers are told the same thing. Okay? This is not the world that we typically think of where the supplier or the firm gets to set its price. Okay? This is the idea here is that they're just told, all right, you can sell it for $2. How many do you want to sell? Boom. Right? And so what ends up happening is that they arrive at a price, the market arrives at a price where the people who want the number of goods is equal to the people who want to sell the number of goods, right? And this is, I mean, it's kind of like a no-duh outcome, right? If we're at that point, everybody's happy, right? Everybody who wants one's getting one. Everyone who wants to sell one is selling one, okay? And so we call it the price that does that is we call it the equilibrium price, the equilibrium price, okay? And then, of course, the quantity that is both supplied and demanded at that price is called the equilibrium quantity. Okay? Remember, it's both the quantity demanded and the quantity supplied, because only at the equilibrium price are those two quantities equal. Okay? Anytime you tell me an equilibrium, in order to fully characterize an equilibrium, you need to tell me two things. Because the equilibrium, right, is just a point, and a point tells you two pieces of information. It tells me your x-coordinate and your y-coordinate, right? So anytime you tell me an equilibrium, because an equilibrium is just a point, you need to tell me two pieces of information, right? You'll need to tell me the price, and you'll need to tell me the quantity, right? That's how to fully characterize an equilibrium. Okay, does that make sense to everybody? And if you have just a supply schedule, it's pretty easy. You just find the spot where the quantity demanded equals the quantity supplied. If you have a graph, it's also pretty easy. You just look for the place that the graphs cross. Okay? Let's go into that just a little bit more. So I made the claim that this was an equilibrium, meaning the marketplace just kind of ends up at this price. Let's imagine that the price was too high. Let's imagine that the marketplace determined that the price was $5, or that for some weird reason it was in equilibrium and somehow the price got bumped up, right? I'm making the claim to you by calling it an equilibrium that if the price gets bumped up or bumped down, it'll find its way back all by itself, right? That's what equilibrium means. So let's say the price gets bumped up to $5, okay? So look at the information on this graph. It's telling us that quantity demanded at $5 is way down here, is 9 lattes, right? So how much do people demand? 9 lattes. What about quantity supplied, though? 25 lattes. Now, this makes sense. If the price is too high, not very many people want to buy them because, right, a high price is bad if you want to buy it. If the price is high, though, a lot of people want to make it because a high price is good if you're the firm producing the latte, right? Well, we have this issue. What is it? Is the quantity demanded and quantity supplied the same number? No.
Absolutely not, right? There's a surplus of 16, right? 9 people are going to buy them, but they're going to make 25 of them. That means there's 16 lattes left over. Okay? We call that a surplus or excess supply. It's just when quantity supplied is greater than quantity demanded. Okay? There's a surplus of lattes. So there's too many lattes sitting out there on the counter at the firms. Naturally, what do all firms do when there's an excess of inventory or they have too many things? They put them on sale. Exactly. So they drop it to $4, let's say. Okay? So sellers try to increase sales by cutting the price. Now, does this help the surplus problem? It does, in fact, help it a little bit because, look, now we have, instead of, what was that, 9 people wanting to buy, we have, I don't know, what's that, 11 people wanting to buy? And the amount of people who want to produce them, or the amount that the couple of firms want to produce, goes down because they're not making quite as much profit per unit, right? And so the surplus does shrink. But the price is still too high here, right? Clearly. There's still excess inventory. There's still lattes that are not being sold. So, like any good firms that are profit maximizing, they're going to cut the price again up until the equilibrium point. This is the equilibrium price. And that's how the price gets back down to the equilibrium, right? So even though in this marketplace we've kind of been like imagining that they show up at the market and somebody just tells the buyers how much the price is and tells the sellers how much the price is, there's really no one in the buyer. It's just the coordinated actions of the buyers and the sellers, right? There's so many of them that when they're just kind of arguing with each other and trying to rip each other off, aka get a good deal for myself, right? They arrive at this equilibrium point. And it's extremely stable. That's why we call it an equilibrium, right? Equa meaning equal or not moving, not changing. So that's how the price works its way down. Let's imagine if the price gets knocked down too far, right? And so the price is too low. It's below the equilibrium, okay? So let's imagine we have the price being $1, okay? Just suppose. Well, let's read the information on this graph. So the amount that people demand, because the good is really cheap now. The amount that people demand, we read that off the demand curve, it's really high. It's like 21. 21 lattes that people are demanding. Okay? But immediately you should look at this and see there's a problem. How much are people wanting to supply of the lattes? Only 5, right? Because they're not selling them for enough. There's no possible way for the firms to make any more than that given the low price, right? So for some reason, the price got bumped down too low. Now we got all these people. We got 21 people lined up to try to get 5 lattes, right? And so the firm owners are like, oh my goodness, there's a big long line. Like any good firm, profit maximizing firm, what are they going to do? Raise prices, right? To overcome this shortage. So there's the shortage of 16 lattes. There's a line out the door. They raise price. Okay? They raise it, let's suppose, to $2. Okay? Well, quantity demanded falls. That's nice, right? Quantity demanded falls. Quantity supplied rises because now the firms can make more because they're getting more per latte. There's still a shortage, though, because we haven't raised the price all the way up to the equilibrium price. Okay? They're going to keep raising prices up until you get to the equilibrium price. Right? So this point is remarkably stable. In a marketplace without any interference from, say, the government or from market power, from big monopolists maybe that are in the area, if everyone is just a small buyer and a small seller and there's thousands, an infinite number of them, right, you're going to get this extremely stable equilibrium price. So, all right, so that's why we call it the equilibrium price. This is kind of like the place we're always looking for in economics, right? In this class specifically, it seems like all we do is just draw curves and find out where they cross and label that point. But the points are really important, okay? While it might be easy to find this point right here, you got to really understand what it means, what that point means, okay? Exactly. So the question is why, if they're making at $1, if they're making 5 and the price raises, why do they make more? Exactly. The supply curve is the listing of the quantities that will maximize the profit for the supplier firms, right? So the supply curve is telling us that at $1, the profit maximizing quantity for a firm to make is 5. If they can have the chance to sell at $2, the profit maximizing quantity is going to be 10, okay, for the firm to make. Right? These firms, we're not assuming that these firms are idiots. No, we're assuming these firms are highly sophisticated, experienced firms in the market. Right? Eventually they'll get there, even if they don't start out being that sophisticated. They know their production technology, their cost function. They know how to maximize profits. Okay? And so that's basically what the supply curve is telling us. It's the listing of the profit maximizing points. Okay? For this kind of marketplace, for the perfectly competitive marketplace. All right? And that's because those of you who've taken micro, you'll remember that the supply curve is actually just the marginal cost curve of each firm. And in a perfectly competitive firm, price equals marginal cost. So this, by definition, is the profit maximizing point for every dollar value. Okay? All right, so now let's see what's going to happen. Remember we talked about all these non-price determinants that could shift either the supply curve or the demand curve? Okay, let's analyze one of these effects. So let's imagine that something happens in the economy, and we have an original point. We have an original supply curve and demand curve, right? An original equilibrium price and an equilibrium quantity. Okay, let me label my axes. That's price. That's quantity. Okay, we'll call those P1 and Q1. And something happens, right? And this is a real common economics problem I could give you. First thing, decide whether the event shifts the supply curve, the demand curve, or both. That's step 1. Okay, this is really important. Supply curve, demand curve, or both. 2, decide in which direction the curve shifts, left or right. Remember, we talked about that last class when, for example, an increase in the demand, right, would make the demand curve shift out like this direction. And an increase in supply would make the supply curve shift out to the right in this direction. Okay? And then finally, draw a graph for it. Draw a graph. I am always continually surprised to see the number of students who forget this step. They just try to kind of do it in their head. They're like, oh, yeah, more people are wanting to buy this good, so price must go up and quantity must go up. And then, yeah, that makes sense. Just draw a graph. I draw a graph still when I am analyzing these effects. Okay? And then we'll just look at the new quantity and the new price in a move. Okay? So let's do a practice one together. Let's say we're in the market for hybrid cars. Okay? So I'm going to put my axes up there. Remember, the first thing that you always do when you approach a graph, you don't look at what's in here. That's why I don't have anything in here yet. What do you look at? What's on the axes, right? So you can think about what's going on. Price of hybrid cars, quantity of hybrid cars. Boom. This tells you right away price and quantity of hybrid cars. This is a market for hybrid cars, and I'm drawing either a supply or demand curve. Those are the only curves that I know that are drawn on the P and the Q axes. Okay? So I'm drawing either supply or demand curve. Probably both, because this is economics class. Okay? So I'm just going to draw a random supply curve and demand curve. I always remember it. Demand points down, supply points to the sky. It seems like when I come up to the board sometimes, my IQ level drops by like a couple points, and I just flip them around all the time. So easy to remember. Supply goes to the sky, demand points down, and I have an original equilibrium point. Boom, right? So this means that as it sits, this marketplace is in equilibrium. They arrived at a price. Well, first of all, there's an infinite number of buyers. There's an infinite or many number of sellers. Nobody has any price setting power. They're all price takers, right? Whatever the price of the hybrid car is given to them, boom. They can't have any. They just make a decision to make themselves happiest, or the suppliers make a decision to maximize their profit based on that price. They can't change the price. And so anyways, they get to this price called P1, and they're going to be buying and selling Q1 cars. Okay? Everybody's happy in equilibrium, right? The suppliers, they're producing as many as they want to. The demanders, they are buying as many as they want to. Okay? So now let's imagine that a shift in demand occurs. All right, so I have this is my old, like, previous equilibrium. I'm going to have a shift in demand. What causes it? An increase in the price of gas. Okay, so here's where your intuition got to take over a little bit. This is the market for hybrid cars. Increase in the price of gas. What's that probably going to do for people who want to buy hybrid cars? It's going to increase the demand, right? If gas gets more expensive, more people are going to want to buy hybrid cars. The reasoning that from the beginning of the chapter that we would call it is a shift in tastes or preferences. It falls into that category, right? People prefer a hybrid car now. So it's going to make the demand curve shift out, right? OK, so that's step one. The demand curve shifts, right? The also important thing for step one is to figure out what curve does not shift, right? So does the supply curve shift? No, exactly, all right? Supply curve does not shift. Now, this is really important, OK? Let me tell you a common mistake that a lot of my students make. They think, whoa, gas prices go up, more people are going to buy hybrid cars, so more people are going to have to sell hybrid cars, right? So I'm going to shift the supply curve out. That's not right. Because remember, the supply curve, you can increase quantity along the supply curve by staying on the same supply curve, right? If you need to shift out quantity, you can just stay on the same supply curve. What we're looking here is anything that's going to change the firm's profit maximizing problem or the firm's production technology, right? We have to imagine that we're just the firm. So given that in my firm I don't use gas as one of the inputs, right? And maybe I have a factory and I need gas or something, and then that would change my costs and that would change my supply curve. But pretend that doesn't happen. I just make hybrid cars and the only input is labor. That's a common assumption I make in this class, right? My only input is labor, just to make it really easy. And so this has nothing to do with my supply curve, right? It didn't change my costs. It doesn't change the number of sellers in the marketplace. Okay, so the supply curve stays still. However, the demand curve, in fact, does shift. Okay, now which direction does it shift?
It shifts to the right.
To the right is right. Okay, absolutely, because that's going to be an increase in demand. An increase in demand, right? Because it makes it better to have a hybrid if the car goes up, if the price of the gas goes up. Okay. So that's step two. Then step three is finally put it all together on the graph. So let's do that. Draw the new equilibrium point. This is probably, once you've got the graph drawn, this is the easiest step. Okay? If you don't have a graph, this is going to be a really hard step. Right? You just find the new equilibrium point right here. And it's easy to read off the new point. It's at P2 and Q2. Right? P2 and Q2. So knowing that an equilibrium is fully described or fully characterized by price and quantity, right? When you tell me what's happening in this marketplace, you have to tell me what's happening to price and to quantity, right? So not too hard. Price goes up, quantity goes up, right? Does that make sense? And that's all because of this shift in demand. Supply curve, don't forget, did not change. Supply curve did not change. Here's the reasoning behind it, right? Producers are making more hybrids, right? Suppliers are, in fact, supplying more vehicles. But how did that, what convinced them to make more vehicles? The higher price, right? The price went up, so the suppliers decided to make more vehicles, right? When more people want the car, one of two things has to happen. One, more people have to make them, or the cars have to get more expensive to make people not want them anymore, right? To make it not so attractive. And we see both of these things occurring in this model, right? The suppliers are, in fact, making more vehicles, but the price is also rising a lot, which helps offset how attractive or how much people want the hybrid cars. That's how we get to this equilibrium, right? Because if the marketplace had stayed at this price P1, but then the demand curve shifted, we have a problem, right? Because all of a sudden, all these people are going to be wanting cars, but not a whole lot of people are going to be supplying them, right? So both changes had to occur, okay? Always be careful to distinguish between a shift in a curve and a movement along the curve. My students always accidentally mess this up, all right? And I've already said this once, I'll say it again. The thinking, and I can understand the thinking, right? Be like, oh, demand went up, so more people got to make more cars to satisfy that demand, so the demand curve must have shifted, or the supply curve must have shifted also, right? That's not true. What happened is we have a shift along the supply curve, right? So that was a shift along the supply curve. That was a movement along the supply curve versus a shift in a curve. And there's two different terms that we use to talk about that. If I say a change in supply, this did not occur in this last problem, right? We did not have a change in supply, right? But if the whole supply curve changes, we call that a change in supply. We represent that by a shift in the supply curve. And it only occurs when some non-price determinant of supply changes, right? Because if the price changes, then I just slide around the curve. Anything but price, remember, anything but price changes, the curve itself moves, right? If price changes, then I just slide along the curve, okay? So anytime something not price changes, a non-price determinant, my whole supply curve moves in the graph, okay? And then if I just am sliding along the same supply curve, I call that a change in the quantity supplied, right? So you see the difference between supply versus quantity supplied? All right, I've highlighted this slightly already in the previous lecture. But notice the difference between supply, meaning the whole curve changing, and quantity supplied, meaning just sliding along the curve, okay? And this occurs when the price changes, right? So if it's a non-price thing, it's a change in supply. If it's a price thing, it's a change in the quantity supplied, and I just shift along the curve.
Is this just for the supply?
This is a good question. This is not just for supply. This is also for demand, okay? So demand has the exact same terminology. So if I call it a change in demand, this means that the whole demand curve is moving. And this has to be due to a non-price determinant, okay? So in the example of the market for hybrid cars, what caused the change in demand? Because this thing did happen in our last example. It was the increase in the price of gas, right? So the increase in the price of gas changed people's preferences or changed their tastes. That's a non-price determinant, right? People's preferences or people's tastes. Non-price determinant. The demand curve shifted, okay? And if, though, we just have a price change, if we just have a price change and the demand does not shift, the demand curve does not shift, we call it a change in the quantity demanded, okay? And it happens when the price changes. This is a really important slide, okay? As far as knowing how to draw these new equilibria points. Great. So the question is, isn't it the thing that changed in our model, in our example, was the price of gas? So isn't that just a price change? Very good question. The answer is no, because when we're in the market for hybrid cars, that's the quantity of hybrid cars. This is the price of hybrid cars. So only the price of the thing in the marketplace we're talking about. So if it's the price of something else, like the price of gas, which is not the price of hybrid cars, that's going to be considered a non-price determinant of demand. That is a very good point, okay? Because don't forget, there are also like complements and substitutes. And if complements and substitutes change their price, right? So if the price of hamburgers goes up, then looking in the marketplace for pizza, we're going to treat that as a non-price determinant. Even though it is a price, it's not the price of pizza. If it's the price of hamburgers, that's going up, okay? And I'll let you guys do an example in a couple minutes. We'll do one together that has exactly that point. But it's a really, really good point to note that when I say non-price change, I mean non-price of whatever good that we're analyzing, okay? Really good question. OK, now let's go ahead and talk about what happens if supply shifts, right? here's going to be how we get there. Some new technology reduces the cost of producing hybrid cars. Okay? So you're going to think that. Imagine that I hadn't told you this. Imagine I hadn't told you this. You didn't know this. I just tell you this because I promise if I give you a problem, I won't tell you this. That's too easy. I'll just tell you the event. Okay? And you have to think, what would that do in the market for hybrid cars? Okay? So step 1 says, what curve changes? Okay? Let's think. Does demand change? Demand is something that's going to make the people want to buy more cars, right? Me and you as consumers of hybrid cars, do we really know or care anything about the technology of making hybrid cars? No, right? OK. So, whoops, I skipped this. So demand curve does not shift, OK? Because production technology doesn't affect the buyers. It affects who? The sellers, the suppliers, the firms that produce the vehicles. So what curve is going to shift?
S curve.
Exactly, the S curve. And if you can think this through, it's going to make it cheaper to produce hybrid cars, okay, and more easy to produce hybrid cars. So how is the supply curve going to shift?
Shift to the right.
To the right. That's step 2. Exactly. It shifts right. And let's think about what that means. Basically, it's saying that for any price point, P1, P2, whatever, the firm can profitably create more cars now because each car is cheaper to make. Okay? And that's the idea behind the supply curve shifting out to the right. We call this an increase in supply, a change in supply, right? This time, a non-price determinant of supply is changing. A non-price determinant of supply is changing, which means we have to move the whole supply curve. Okay? We have to move the whole supply curve. And then finally, we find the new equilibrium in step 3. And I can look, and it's right there. And so I call it price is falling and quantity is increasing. Price is falling and quantity is increasing. Was there a change in demand? No, there was no change in demand. Very good. There was a change in supply, no change in demand, right? The number that people wanted actually went up, right? Because people are buying more cars, so people are wanting or demanding more cars. But that's just a change in the quantity demanded along the same demand curve. Okay? So we have price falling and quantity increasing. And that makes sense. If you think about what it is going on here, hybrid cars are getting cheaper, right? So in the marketplace, they should be selling for less, and there should be more people buying them. And that's exactly what's happening. Right? So the economics intuition can make sure we did this right also. Okay? You shouldn't get something you're like, what on earth is going on? I don't know. Okay? Any questions at this point? Question: If a business could lower its supply curve, maybe lower its costs, it could get a whole lot more customers than everybody else. That is true. However, don't forget that in this really simplified, perfectly competitive marketplace, we're assuming that everybody has the same supply curve and everybody has the same everything. So if some firm invented some way to lower his supply curve, lower his cost function, it's immediately copied by every other firm. That's the way we can think of that in this. And there are plenty of markets that are like this, right? People just immediately copy, and then you don't have an advantage anymore. Okay. All right, now let's get a little crazy. Let's shift both curves at the same time, right? What are we going to do? OK, so we have gas rises, the price of gas rises, and we have a reduction in costs. Okay, so we already know what curves are going to shift. Both of them are going to shift, right? Supply is going to shift to the right. Demand is going to shift to the right. Okay, so we're going to draw that just like this, right? And so what do we know about the new equilibrium? Okay, what do we know about the new equilibrium? Well, let's draw this point right there. The way I have it drawn right now, price went up and quantity went up, right? But careful, wait for a second before you think of that for sure. What if and the reason why that happened is because I made the demand jump a lot and the supply curve only jump a little bit. But I could redraw this a different way, where I make the supply curve jump a lot and the demand curve jump a little. And now notice, the price is actually lower than it was before, but the quantity is still higher. Okay? So the key is here, when you have two curves shifting, you're going to have one of the things you know for sure, and one of them you have no idea about. Okay? It just depends on how the curve moves, how the curves move. Okay? And when we have something that moves for sure, oops, let's go back. When we have one that moves for sure, we call that unambiguous. You guys have heard the word ambiguous before? Ambi meaning both, right? So it could be either. So if it's unambiguous, it means it's clear, right? So Q clearly increases. But the effect on P, we call that ambiguous, right? Ambiguous, because it just depends on how I draw the graph, right? If I draw it where demand is coming out a lot, well, then there's a lot of demanders, so the price is going to go up. If I draw it where supply is going out a lot, meaning it's getting way cheaper to make the hybrid cars and not that many more people want to buy them, the price is going to go down, right? So the effect on price is called ambiguous. That means we're not sure. The effect on quantity is not ambiguous. We know for sure it goes up. Does that make sense? Now, it would be incorrect to tell me, OK, so this would be incorrect, so don't do this, that quantity increases and price decreases. That would be a wrong answer. All right? The only right answer when you move two curves, is that we get in this bit of a hassle. The only right answer is to say quantity unambiguously increases. The effect on price is ambiguous. Okay? Or you don't have to use those exact words. Okay? You can say, we surely know that quantity goes up. We don't really know what happens to price. You could say that too. Okay? But when we have two curves moving, only one of the pieces we're going to know for sure. The other one we're not going to know. This happens every time you have two curves moving. Okay? All right. You guys have your chance to practice this. So here's what I want you to do. I'm going to give you 3 events. I have in your handouts a place where you can draw the original equilibrium, right? So you're going to have to draw the old supply, the old demand, and the old equilibrium. It doesn't matter exactly how it looks. Make it look however you want. Okay? And then make this happen. Boom. A change in a fall in the price of CDs. Tell me a new price and a new quantity. Okay? And then, once you're done with that, draw another old supply, old demand, and then analyze event B. Oh, one real quick before you start, let me explain this to you. Sellers of music downloads negotiate a reduction in the royalties they must pay for each song they sell. So remember, this is the market for music downloads. And the factories or the firms that are producing the music downloads, like iTunes, right? They have to pay the artists to buy the songs to sell, right? So if iTunes gets to pay fewer royalties to Shakira to sell her song or something like that, that's what a royalty is. It's the amount of money you have to pay to the singer. Okay? So you're going to have to imagine how that changes the market for music downloads. Okay, ready to go. Let's check this out. Let's do event A, a fall in the price of CDs. Okay, so we have the market for music downloads. That means our axes are quantity and price of music downloads, right? I have an original supply, original demand, original price, and original quantity. Everything's in equilibrium. Boom. What's the thing that happens? A fall in the price of CDs, right? So step 1, what curve shifts? Demand curve does shift. Who can tell me why it's the demand curve that shifts? Exactly. So the answer is for when the price of CDs goes down, people buy more CDs, meaning they buy fewer music downloads. Okay? So we can think of that as a change in the price of related products, right? Specifically, it's a product that's called a substitute, right? I could buy a CD if I want to listen to the music, or I could download the album on iTunes, right? Either one. Okay, so demand curve will shift. Will supply curve shift? No. Okay, it's just as important to figure out which curve doesn't shift. All right. this supply curve, remember, is only production technology for producing the songs, right? The factories that make these songs, iTunes, however iTunes gets it, or whatever other website you go to download your music from, legally, of course. OK, so the demand curve shifts. Step 2, which direction does it shift?
Shift to the left.
The left, exactly. And the reason, as we've already stated, is because people are buying more CDs now, so they're buying fewer music downloads from iTunes. OK, and then step 3, boom, let's put our new equilibrium point. We have price going down and quantity going down. Are either of these ambiguous? No. Remember, the ambiguous problem only happens when you have both curves shifting. If you only have one curve shifting, you're good. Okay? So let's use economic intuition. Does this make sense? If less people want to buy music downloads, then OK. Yeah, less people are going to end up buying them. That's what Q going down is. And they should also get cheaper. Yes, because people try it. The iTunes, when it sees that fewer people are buying its downloads, it's going to lower the prices. Maybe it's going to put the albums on sale, right? Maybe make them $9.99 whole albums or something like that to try to induce people to grab them. And we find now, actually, that the price of an album on iTunes and the price of the album if you just buy the CD are almost identical nowadays, okay? Because of this effect, right? It dropped the price, or it raises the price until the price of the two goods are actually pretty close nowadays. OK, any questions on what happens in the fall price of the CDs? OK, pretty easy. Let's do a fall in the cost of royalties. Okay, meaning that iTunes can get the songs for cheaper from the artists, right? So what curve shifts? Supply, right? Because we're talking about getting an input, i.e. the song from the artist, right? We're talking about getting an input. So this is the same as saying my input prices or my factor prices are getting cheaper, right? A fall in the cost of input prices, right, changes the supply curve. Okay? So that's another example, actually, of a price that changes, but we treat that as a non-price determinant because it's the price not of the music download, it's the price of the input that's falling. Okay? So the S curve shifts, very good, and it shifts in, oh, does the demand curve shift, by the way? No, it's important to know the demand curve is not shifting. Okay? Which direction does it shift?
To the right.
To the right. It's making it cheaper to produce this good, so I'm going to be able to produce more of the good at every price point. And so my new equilibrium is here. And in order to fully characterize this equilibrium or fully describe this equilibrium, you have to tell me both a price and a quantity. So it's P2, Q2. And this is not ambiguous. We know for sure what happens to both of them. For sure what happens is that price goes down and quantity goes up. Okay? Let's use economic intuition and check and make sure this is OK. If it's getting cheaper for iTunes to provide me the songs, I should get to pay less. Yeah, OK. And I should get to buy more, or people will buy more. Yeah, that makes sense, right? So this is clearly making sense and probably the right answer. OK? Now, both of them are going to happen. All right, let's do that. Let's do that craziness. So let's go supply curve shifts. Right, let's call this S prime. And let's do demand curve shifts. OK, so we have something that looks like that. Now, when we have two curves shifting, do I have any problems with ambiguity here?
Yes.
Yeah. So that means one of the things I'm going to know for sure, one of them I'm not going to know for sure. OK? So we got D curve shifting left, the S curve shifting right. OK, perfect. Oh, can you tell me which one we're sure of by looking at this graph? Can you tell me which one we're sure of? Price.
The price.
Price for sure is falling, right? Because you can just imagine in your head, what if I made the supply curve shift really small and the demand curve shift really big, right? I'd have something like over here. And if I flipped it around, if I made the supply curve shift really big and the P curve shift really small, I'd have something go over here. So no matter what, price is always unambiguously, that means surely, unambiguously falling. Okay? And the ambiguity problem shows up in the quantity, right? It just depends. I happen to make my supply shift a little bit bigger than my demand shift, so my quantity increased, right? If I made my demand shift really big, right, we'd be over here somewhere, and the quantity would decrease, all right? So we have this ambiguity problem with quantity, okay? So because we have the two effects that are kind of going against each other. The fall in demand, meaning fewer people want this good, is making the queue get smaller, but the fact that it's getting cheaper to make it is making the quantity go bigger, right? So we're just not sure which one offsets each other with this limited information, right? Maybe if I told you that we know for sure this fall, or the increase in supply is bigger than the fall in demand, well, then we can know something, right? But just with the information I gave you, we're stuck in this ambiguity problem. OK? So does that make sense? Sweet. So in conclusion, basically, it's important to note that we arrive at an equilibrium by the price, right? It's the price that's moving up and down. And the price naturally falls in this place called an equilibrium, where the quantity supplied is equal to the quantity demanded. Okay? And that's how we got this idea. Remember one of our 10 principles from Chapter 1, that markets are usually a good way to organize economic activity. Okay? If we hold on to these assumptions that there's no market power, that there's a lot of mini buyers and a lot of small sellers, right? There's no real big monopoly or anything that can ruin the marketplace. And there's no government intervention. The market all by itself is going to organize economic activity. It's going to decide a price. It's going to decide a quantity. It's going to decide who gets what. Okay, all by itself. And there's not really a boss in charge of the market, is there? Right? It's just decentralized. It's just people interacting with each other. We call that the marketplace. Right? So basically, it's just, another way to put this around is, if you just let people argue with each other and try to rip each other off and try to get the best price possible, you're going to have, all by itself, this outcome that is an equilibrium, that quantity demanded is equal to quantity supplied. Okay? And the way it works in the market economy is it's the price. It's the signal. It's the signal both to the buyers of how much I'm going to decide to buy, and it's a signal to the sellers how much I'm going to decide to sell. Okay? And that is why it's really important that in this kind of a marketplace, we let the price fluctuate. Right? We can't try to control the price, because if we try to control the price, then that's the signal that everybody's looking at and taking on. It's going to mix up everybody in the marketplace, and then we're going to have either supply surpluses, or we're going to have shortages, or we're going to have some sort of a problem. Okay? So the idea is that if we let price go by itself, people argue with each other, try to rip each other off, we're going to have the best distribution of the goods possible.